Assalamualaikum and hello everyone. My name is Nurul Nadia binti Jamaluddin, and today I will present to you about the apparatus that we use for hypot test in high voltage based on Hafley Manual Kit 4.0. So, based on the lab experiment that conducted by our lecturer, Dr. Zikri Abadi, the task given asked us what apparatus that we used in the lab session. So, the apparatus being used in hyper test are the test transformer 100 kV with power 10 kVA type PZT 100-0.1. Next, the measuring capacitor type CM, the connection rod type V, grounding switch type ES, the connection cup type K, the secondary part for CMAC type SEKAC, the sphere gap type KF, and the last one is the top electrode type EL. So all of these apparatus are being used for high voltage hypot test. Next, I will describe the main consideration of the transformer winding property for the transformer to be function as generating high voltage level and isolating transformer, V input 240 volt and V output 240 volt. So, frequency converter must be connected properly and at correct point with transformer. As stated in the nameplate at the transformer, the 2px must contact with the 1pu so that when the system operates, the whole potential from 1px to 2pu will be obtained. Other than that, the connection state in nameplate is important to the transformer to be function as generate high voltage level and isolating transformer, V input 240 volt and also the V output 240 volt. And the potential from 1 to 100 kV as well. So here, as you can see, the figure 1 show the schematic design of transformer, and figure 2 here show the circuit of frequency converter with connect to the transformer tap point. Now, I continue with the presentation about what is capacitive voltage divider and describe what two types of capacitor that exist in the capacitor that being used in high voltage hypot test. So, the first one is voltage divider circuit are used to produce different voltage level from a common voltage source, but the current is still the same for all components since the circuit is in the series connection. Second, the connection between transformer and capacitor are connected by using iron conductor or 2.5 mega ohm resistor. Beside that, from the capacitor, which is 100 microfarad, the coaxial cable are being used to connect with secondary AC device. Next, voltage divider consists two type of capacitor with series connection, and one of them is rated by 100 microfarad, while another capacitor are rated with 2 microfarad. Since the small value of capacitor will produce high value of voltage drop, which is 100 microfarad capacitor, are being used. Furthermore, the secondary capacitive device must have the right serial number according to what type of machine that they use. For this lab experiment, capacitive device with serial number of 22341076-04 are being used. So the results state that the value for secondary device is 1.94036 microfarads. The rated value is 2 microfarad and rated voltage is 7 BRMS. Since the probe can only hold 7 BRMS, the voltage divider concept is being used so that the power can safely be supplied to the system. Continue with the previous slide. The grounding connection from frequency converter into transformer is connected with mesh copper braided cable. This is because the grounding connection must have less than 2 ohm for a safety purpose. Since the safety is very crucial and important, whenever the connection was done, the transformer grounding will be connected with secondary grounding by using the same cable, which is the copper braided cable as well. And here, as you can see, the left figure show the capacitor that being used in high voltage hypot test, and in the right one show the circuit diagram of capacitive voltage divider that connected with transformer. That is all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shahinda binti Rahim. Today I'm gonna present to you my part, which is secondary capacitor. Okay, as we can see at this slide above, at this circuit, for the voltage supply is 100 kilovolt. Okay, 100 kilovolt supply we get from secondary transformer. Okay, for the capacitor one, the above one, it is for high voltage, and the below one, capacitor two, is for low voltage. Okay, as we can see that capacitor high voltage is 100 picofarad, while capacitor for low voltage is a 2 microfarad. Okay, we can see that both capacitor is connected in series across an alternating supply of 100 kilovolt. As the two capacitors are in series, the charge Q on them is the same, but the voltage across them will be different and related to their capacitance values, as V is equal to Q over C. Okay, a capacitive voltage divider network is not affected by changes in the supply frequency, even though they use capacitors, which are reactive elements, as each capacitor in the series chain is affected equally by changes in supply frequency. Okay, as we know that capacitor consists of two parallel conductive plates separated by an insulator, and one of them has a positive charge on one plate, and the other one, the opposite, is a negative charge on the other. Okay, when it is connected to a DC, that is direct current supply, once the capacitor is fully charged, the insulator that we call the dielectric blocks the flow of current through it. Okay, let's move on to the next slide, which is calculation of capacitive voltage divider. Okay, after I make a calculation for voltage divider, I found out that voltage drop at capacitor high voltage is 100 kilovolt, while voltage drop at capacitor for low voltage is 5 volt. Okay, 5 volt is the voltage used, voltage drop there, but the maximum voltage drop is 7 volt. Okay, um when the capacitor's values are different, the smaller value capacitor will charge itself to a higher voltage than the larger value capacitor. And for our example above, this was 100 kilovolt and 5 volt respectively. Since Kirchhoff voltage law applies to this and every series connected circuit, the total sum of the individual voltage drop will be equal in value to the supply voltage Vs. Okay, for my last part is schematic structure of the secondary capacitor. Okay, as we can see the circuit, we use a 20 capacitor, values are 0.1 microfarad. Okay, all the capacitors are connected in parallel. Okay, Why it is connected in parallel? It is because by connecting several capacitors in parallel, the resulting circuit is able to store more energy, since the equivalent capacitance is the sum of individual capacitances of all capacitors involved. Okay, that's the reason why it is connected in parallel. Okay, then the connector above, there are two connector above, which is two female connector coaxial cable BNC, one for input and one for output. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mahimi. I am from BEEI Section 1/2, and today I am covering topics about coaxial cable and diagram connection between frequency converter, secondary capacitance and measuring capacitance. And first, for coaxial cable, middle in the coaxial cable cause a central core, and it made either solid center wire and mix of aluminum and copper. Center conductor called as dielectric acts buffer of sort to keep center conductor isolate and straight. Outside of dielectric is coaxial shield, which usually combine of copper and aluminum foil and wire braid, and offering high voltage handling and low attenuation characteristic for 100 watt, and is capable to withstand extreme temperature, which is to up to 100 degree. This is diagram connection between frequency converter, secondary capacitance and measuring capacitor. The diagram shows 4 equipment frequency converter located at KFC cabinets. Measuring capacitor, which is 100 microfarad, floor pedestal, and secondary capacitance, which is AC, is 2 microfarad. Based on the circuit, connection from frequency converter grounding switch to the floor pedestal, and then the floor pedestal attached to measuring capacitor, because the grounding needs to touch to a top electrode to allow voltage and current through measuring capacitor. Next, the coaxial cable is 50 ohm connect for measuring capacitor to secondary capacitor AC at female connector to male BNC coaxial cable. Before connect to coaxial cable, we need to make sure that female connector and grounding point on secondary capacitance connect properly. Other side of secondary unit capacitance is connect to VM1 port, which located at frequency converter using coaxial cable. VM1 port, which allow maximum 7 VRMS through it and purpose for AC measurement. The grounding system of the floor pedestal attached with the measure capacitance must connect to the ground point at frequency converter. And lastly, make sure the ground of frequency converter, floor pedestal and measuring capacitance need to attach together as termination ground to remain charged flow to the ground. I think that's all from us. Thank you.